It should start recording what we're doing. There it goes. Okay. So let's look at, so now we're going to do f times g. So we're looking at -1. I'm going to find the limit of each one of those. So at -1, it looks like, oh, apparently I've got, no, let's see, at -1. So at -1 f times g, I'm looking at my answer key. Where did I get that one from? So I'm going to start by looking at my right and my left hand limits on both of them, okay? So because I don't really know, it looks like there's some kind of a gap, and since I'm multiplying these together, they might actually turn out to be the same. So I'm going to do the right and the left separately. So the limit as x approaches -1 from the left of f of x times g of x. So as I am coming at f of x from the left, it looks like I am going to 1 for the f. And then as I am coming at -1 from the left of g, it looks like I am going to, I said -1, I meant +1. We're going to +1, which means my overall limit there is 1. Okay. Then I'm going to go the limit as x is approaching -1 from the right of f of x times g of x. All right, so this time, as I'm approaching -1 from the left side, it looks like we are at 2. And then as I'm at it from the left side here, it looks like we are at 1, which means my overall limit is 1. So these are not equal to each other. So overall, the limit as x approaches -1 of f of x times g of x does not exist. All right, let's look at something similar for 2, okay? I'm going to erase my scribbles. So I'm going to do my work kind of out here. I had purple, let's do purple. So we've got the limit as x approaches 2 from the left to begin with of f of x times g of x. So 2, x equals 2 from the left looks like it's 1. And x equals 2 from the left of this one looks like it's 0. So I'm going to be 0. Now I'm going to do limit as x approaches 2 from the right of f of x times g of x. So from the right, look, the only place I have from the right is here. So that's at -1. And then from the right on this graph, it looks like it's at 0. So it's 0. So my overall limit is in fact 0 because my right and my left were equal. Okay. As I'm going through, if there's anything that's confusing you, please stop me. Okay. Okay, let's take a look at the next one. Okay. And we're going to have this craziness go on again. When I'm looking like it's like a does not exist type situation, this is where I invoke the from the left, from the right. Okay. So I'm going to kind of move my work out here. I'm going to look at 2 times the limit as x approaches 0 from the right of f of x, plus 3 times the limit as x approaches 0 from the left of g of x. I'm going to do my left first, and then we'll go in and do our right. And I erase again. So we're going to 0. So 0 from the left, oops, is definitely equal to 2. So it's 2 times 2. And then 0 from the left on G is 0. So plus 3 times 0. So we end up with 4 plus 0, or just 4 on that one. And now we're going to look at 2, oh, that's terrible on here. 2 times the limit as x approaches 0 from the left of f of x, I'm sorry, the right, plus 3 times the limit as x is approaching 0 from the right of g of x. All right, so I'm going to go back to my graph. 0 from the right here is equal to 1. So I have 2 times 1 plus, and I'm going to have 3 times 0 from the right. 0 from the right is 0. So what happened? It wasn't a 1, was it? I counted wrong. It's 2 here. So that's 2 times 2 is 4, plus 3 times 0 is 0. So my overall limit is 4, meaning that my right and my left were equal. So it is in fact equal to 4. Are we doing okay? All right, because I've got about, what, 6 more minutes, okay? Because I have to actually teach fourth period. All right, let's look at this next one here. Hopefully you're getting the hang of it with these. These are tricky, okay? But I think some of us are ready for the tricky ones, okay? And they definitely make the brain think a little bit more. So what is going on with this one? This one's a little bit weird. Well, this one's a lot weird. So what this is doing is it's basically shifting our limit when we have this in parentheses. So it's the equivalent to saying the limit as x approaches 2. We're going to take this here because basically what we're doing is saying, hey, add 2 to whatever you're doing. So it's going to be 2 from the right of just f of x. It's the same thing as saying that. Okay. So I'm going to go. I'm looking at f of 2, so making sure I'm doing it right. Sorry, I said right, I meant left. Okay, so let's try this one. So we're 2 from the left on f, right? So 2 is here from the left, looks like it is equal to 1. Okay. The next one says, I'm just looking at the answer, sorry. I'm going to look at -1 from the left, and then we're supposed to technically square our answer. So looking at my F graph, -1 from the left. Let's start there. So -1 from the left is 1. That doesn't make sense. It's an inner function becomes a positive value very close to 1. This produces the limit as x approaches 1 from the positive. Oh, I get it. Okay. All right, so this one's weird. It's a composition of functions, but it doesn't look like that. Okay. So what you have to do is you have to do f of the limit as x approaches -1 from the left of x squared. Okay. So I'm actually looking at what's going on when I put -1 into x squared. When I put -1 into x squared, I would get something that's about 1, right? So it'd be very, very close to 1 as I'm approaching 1. So by substituting this into here, I would get +1. Now I'm going to go find f of 1 on the graph. Well, when I go to the graph and I'm looking for f of 1, notice that the value is not what I expected it to be. It was supposed to be, oh, this produces f of 1 from the right, which is 0. See, these are even challenging for me. We're going to toss that one out. It's supposed to be 0. It's supposed to be that the limit, but then you have to find the limit of the outer one as it approaches this number from the right side. So in other words, x squared approaches 1 from the positive right side. Yeah, just type in a 0 to check it. I'm not putting that one on the test. That one's too tricky. All right, let's look at these ones. All right, I found a really tricky worksheet, right? I put them all on there, and sometimes there's 1 or 2 that I catch that my brain can't handle. All right, so this one, didn't we already do this one? Did I put this one on there twice? Was it +2? I put this one on there twice. Oh wait, or maybe I just copied and pasted it twice, maybe. That's why. We're down here at this one, right? So whenever we have the function composition, just like on that last one, we really have to find g of the limit as x approaches -2 of f of x. And we did have a day where we did these, okay? So I'm going to go to my f graph and I'm going to figure out what I am getting for -2. And it looks like I might have to look maybe at the right and the left. And then that's going to be, okay, so maybe I'm understanding this a little bit better. The limit as x approaches for g of x. Okay, so whatever I get that goes in here for that limit is going to become this value right here, which is what happened on the last problem. So I'm going to go ahead and figure that out. So as we're going -2 from the left and the right, and this is maybe the last one I'm going to have time to do because I got to teach fourth period. Okay, so let's take a look. -2 from the left and from the right. So if I'm looking at -2 from the left, from the right, it looks like we are approaching 0. Okay. So we're getting 0 from both the left and the right. Then I'm going to find the limit as x approaches 0 for g of x. So whatever's inside of here becomes the new value for the limit. So g of x at 0, it looks like from the left and the right is in fact 0. And that should hopefully help you answer the last two. Okay? All right. I hope you guys have a good day. You're welcome. Have a great day, guys.
Bye. Thank you.
You're welcome. So this is, I believe, item 22, and we're going to look at the last 3 here. So on this one here, we are looking, first of all, for the limit. So f of the limit as x is approaching 2 from the left of f of x. So I'm going to go up and I'm going to try to find that on my graph. So looking up here at my graph, and f of x from of 2 from the left side is definitely approaching -1. Sorry, I was looking at the wrong side, wasn't I? 2 from the left side is definitely approaching +1. So that means I know that the limit as x approaches 2 from the left of f of x equals 1. I now need to figure out what's going on at f of 1. Well, but if I look, the problem is if I look at that in the graph, f of 1 is not continuous, so I only get to look at it from one side. I'm going to continue to look at it from the left side. So when I look at it from the left side, I know the limit is going to 2. So again, we do this when it's not continuous. So what that's going to produce is it's going to actually produce the limit as x is approaching 1 from the left of f of x, which we said was 2. This next one here, we're going to look at the limit of x as it approaches 2 from the right of -f of x. So that is meaning the limit as we're approaching 2 from the right. Okay. So 2 from the right is here, which is -1. So I've got negative from here and then a -1, which means we've got f of 1. Okay. And because as we were approaching, because it was a constant function, we now can evaluate f of 1. So f of 1 happens to be 2. All right, and then this last one here, it says that we're going to find the f of the limit as x approaches -1. Very poor color choice, I'm sorry. All right, of g of x minus 2.5. So I am going to go find the limit as x is approaching -1 of g of x. So I'm going to my g graph and I'm looking at -1 and it looks like it's approaching 1. So that's going to give me 1 minus 2.5, which is going to be -1.5. So then I'm going to go to, and we know it's continuous at -1.5 on the f. So I'm going to go find that on my f graph. Okay, so on my f graph, -1.5 is continuous right here. So we're going to look at the value there, and it looks like it'd be about right there, which is about 1/2. So it's going to be positive 1/2. So it's going to be 1/2, or you could type in 0.5. Another question I was asked to do was number 13. So f of c such that f of x is continuous on, find the AC such that f of x is continuous on the entire row line. Well, the calculus is that the limits should be equal on both sides in order to have something that is continuous. So my limit as we approach 4 of both of these functions are supposed to be equal to each other. Well, if I'm going to use direct substitution on this, I could put the 4 in for the x's. So I've got 4 squared equals c over 4. 4 squared is 16. 16 times 4 is 64.